99, sir.
Sorry?
99.
99. How come odd number? 64 odd number. 75. At least I know the logic what they have thought for 75 and 100 I know. And I don't know how come these numbers. Any other answer? I'm just saying, like, even just before this explanation, I told you when you are considering HA, forget one host. That means remove this capacity. How much you can build? 50 plus 50, 100. So 100 is the correct answer. Not 75, I can understand you made it 50-50. Earlier example, it was 50-50, so you made it 50-50. That's wrong. You should count the host, okay, not the percentage. And here, I don't know how come 94, 99 and 64, something odd numbers. It's okay, like, I don't know what reason you have got it, but that was not possible. 100 is the correct answer. So you have to consider HA. When you consider HA, forget about one host. And you tell me now, what if there are 4 hosts in the cluster? And here also 50 VMs we can build. Total you have capacity for 200 VMs. Now you tell me, we have a cluster of 4 hosts. How many, after considering HA, how many VMs can we build here in this cluster?
One 150, sir.
Yes. 150 is the correct answer. Okay. You have to consider host failure, and that much capacity you have to ignore. Okay. Don't consider it. So remaining amount you can build. Up to 15 hosts, I would recommend you to select one host failure. If you have more than 15 ESXi hosts in the cluster, then there will be more failure chances also will be there beyond 15 hosts. Okay, then you can consider 2 hosts for failure at a time. More than 50 or 15 or more than 20, consider 2 host failure, because more hardware, more failure chances will be there. And you don't need to worry about this designing part. You are a solution architect, then team beyond your team. Okay, after your team, there will be one more team who has a lot of experience on this infrastructure. They will design how many hosts you reserve for HAM. But this is a simple logic what they think about while designing the HA. Okay, what if one host fails? When there are more servers, more failure chances will be there. That's why they reserve 2 hosts. Okay, so that's the logic they think. And that number you have to put it here. If you think about one host failure and reserved resources, enter 1 here. If you think about 2 hosts, enter 2 here. Fine, 2 hosts here. Clear? In case of the same capacity, if there are 2 hosts, if you are entering one host here, or you can mention 50% here also. It's the same. You can mention 1 or you can mention 50% there. Both are same. If there are 4 hosts, you can mention 1 here or you can mention 25% here also. Okay? Both are same. Then why we have 2 options if both are same? If you have a cluster with different capacity, let's say here 70 GB RAM, maybe this host is having 50 GB RAM, another host is having maybe again 50. You are placing all of them in the same cluster. Okay, here different capacities. In this case, there is a formula to calculate percentage. Okay, if you apply formula here, we get the better value for reservation. In that case, we can enter this value. Based on that formula, whatever the output that you get, you can enter that value here. I'll give you that formula later. Okay, so I forgot that formula, so we don't frequently use it. And normally, you don't need to worry. 80 to 90% of the people will use first one only. Hardware will be common. Okay, we'll log into vCenter and see. You should know what is admission control and policies as well. Admission control decides if there is enough resources for HA, then VMs will be allowed to power on. If there are no resources, it will not allow VMs to power on. Control policy reserves the amount of resources we reserved. Go to vSphere availability, edit, admission control. Enable HA admission control. Here you can mention 1 or 2. Whatever it is. Okay, how many number of hosts you reserve, you mention that number here, or based on percentage here. Here you can mention percentage. Fine. This percentage value you can set if you calculate based on the percentage. If you set it to disable, we are selecting this one, disabling the admission control. It will allow any number of VMs you are trying to power on, it will allow. This is a dangerous option. Okay. If you select based on this host count or percentage, you can see. Clear? And this is normally the percentage, that value that you set at what percentage stage the VMs will experience performance issues. If 80% of the resources and 90% or 100% of the resource, when will the VMs will be slow? That percentage we can mention. Normally 90% or 80% you can say. But nobody will touch it. We'll leave the default value as it is. Okay. So here is the admission control policy, number of hosts you reserve for HA and percentage of the resources. Clear? So, and it's not a regular task. Once in a while only you will be working with this topic. Any question? HA? So there are many interview questions from HA. I'll just write. What is HA? What is the background mechanism? HA. What is admission control? What is admission control policy? What another thing I said? Okay, these are the interview questions from HA, and there will be other questions with comparison with FT and HA versus DRS. Okay, that we will see. Fine. Any other question? Yeah, if there are only two hosts in the cluster, if one host fails, another host will automatically will be master. Okay, so rest of the remaining host only will be master. Enhanced vMotion compatibility. This is another feature. Well, DRS will take some 1 hour time, so we cannot finish now DRS. So I'm taking another small feature. This is also cluster level feature, EVC. And now this is ES6i1, ES6i2. Okay, here some VMs are running. This is very, very important for interview point of view, but in day-to-day job, once in 2 years only we do them. And even you will not, you may get chance or you may not get chance to work with EVC. So here it is having, let's say, Intel Xeon E5, let's say 2440 processor. I will just think about E5. Here you have Intel, let's say AMD Gen 3. Is it possible to vMotion between these two hosts? vMotion here.
No.
No? Okay, no. And I'll write the definition for EVC and tell me after reading the definition if it is allowed or not. Now read the definition and tell me if it is possible to vMotion in this cluster or not between these two hosts.
Possible, sir.
Possible. Read it again. It should be same CPU family.
No, no. It is not same. Frequency.
Yeah. So vMotion, even with EVC, if you enable normally without EVC, we are sure it is not possible. With EVC also, it's not possible. Yeah. With EVC also, vMotion is not possible. And now, let's say EVC is not there. Now you tell me, is it without EVC? You tell me, is it possible to vMotion here?
No.
No.
Now without EVC. Okay. We are sure that without EVC it's not possible. Now you read the we have enabled EVC now. Read the statement and you tell me is it possible or not.
No, it is possible.
Okay. Now it's possible. Normally it is not possible. If you enable EVC, it will allow us to vMotion. And again, the higher processor should not have any VMs. If there are VMs, it's not possible to enable. There should not be any VMs on the higher processor. Then only you can enable. If you enable, now you can do vMotion here and there within this cluster. So EVC helps us to vMotion if you have a cluster with same CPU family but different generation. Clear? We'll try to understand how it is possible with EVC and why it was not possible without EVC. Okay. So with EVC, let's say E5 processor means there is some logic in the processor, the processing algorithms. E7 means it will have same algorithm plus some extra information will be there. Okay. It's not like completely like i5, Intel i5 versus i7. It's not completely a different processor. It will have the same algorithm plus some extra information for better performance, better security. It will have more features. Okay, so that means here E7 is combination of E5 processor plus some extra algorithm. Clear? Now, here the VMware is taking advantage. When you enable EVC, what will happen, right? So the cluster will become equal to the lowest CPU processing capabilities. All the hosts will be compatible to the lowest CPU features. That means higher CPU features will be hidden. They will be ignored. Only it will degrade. It's a degrade. It's a CPU capabilities. Now, when you're trying to move a VM from E5 to E7, it will see it as a E5 processor only. So that it will migrate here and there. It will understand that it is same generation. So it will migrate. Here and there you can migrate. That's why if there is a virtual machine before enabling EVC, if you have created a VM here, it is already looking at E5, E7 processor power capabilities. This VM you have powered on here, that means it is already looking at the Intel E7 processing capabilities. On the fly, when it is utilizing, you are trying to reduce its CPU capabilities. It is not allowed. అండర్స్టూడ్ ఇది ఆల్రెడీ హైయర్ ప్రాసెసర్ ఫీచర్స్ అన్ని కనిపిస్తున్నాయి, అది యూజ్ చేసుకుంటుంది. మనం ఈవీసీ ఎనేబుల్ చేస్తే ఆ క్లస్టర్లో ఉన్న అన్ని హోస్ట్లు ఏదైతే లోయెస్ట్ తక్కువ సిపియు కేపబిలిటీస్ ఉంటాయో దాని మెజర్స్కి వస్తాయి, అన్ని లోయెస్ట్ సిపియు కేపబిలిటీస్కి వస్తాయి. ఓకే, అప్పుడు ఇది ఆన్లో ఉంది, విఎం ఆన్ పవర్ ఆన్లో ఉంది అండ్ ఇట్ ఈస్ లుకింగ్ అట్ హైయర్ ప్రాసెసింగ్ ఫీచర్స్. అది యూజ్ చేసుకుంటుంది హైయర్ ప్రాసెసర్. నువ్వు ఈవీసీ ఎనేబుల్ చేయాలంటే యూజ్ చేయకూడదు, ఫ్రీగా ఉండాలి. ఇది ఆల్రెడీ యూజ్ చేస్తుంది కాబట్టి ఈవీసీ కూడా ఎనేబుల్ చేయలేదు. ఓకే, యూ కాంట్ ఈవెన్ ఎనేబుల్ ఈవీసీ వెన్ దెర్ ఈస్ ఎ వర్చువల్ మెషిన్ already running on the higher processor. It will not even allow you to click finish button because it is already utilizing the higher capabilities. We cannot reduce when it is utilizing. So we have to power up the VM, then enable EVC if you want to enable EVC in this cluster, right? So the behind logic is all the CPU capabilities will be degraded to the lowest CPU capabilities within the cluster. Now you can do vMotion here and there. Clear? Then why we have paid so much money and purchased the advanced processor? Your latest processor, you are not utilizing it, you are still using the old processor, right? With EVC, your CPU capabilities will be degraded. Then why we have purchased E7? So it will just, EVC will help us to migrate from lower processor to higher processor. After migration, you need to power off the VM cleanly and power on so that VM will get higher CPU capabilities. Okay, you have to power off and power on. Restart also will not help. Power off, leave for 10 seconds, then power on again. If you restart again, it will not see the new features. Okay, it just helps us to migrate here and there. And based on this interview question, it's very, very important, EVC. Even though we don't work on daily basis, interview point of view, it's very important. They will ask what is EVC, how it works, and they will try to confuse you. I have one host with Intel processor, another host with AMD processor. Is it possible to be motion? You are very sure that it's not possible. And after that, you will say there is an advanced feature, okay, called EVC. Are you aware? And is it possible to migrate? Just think about it and tell. So he will ask you like with EVC, it will within the same family. If the generation is different, emotion is possible. If the generation is different, if the family itself different, it's not possible. Even with EVC, if it is AMD, it's not possible to enable the EVC. EVC will not help if you have a host with different families itself. It should be in same family and generation. It can be different. Go to cluster, VMware EVC, edit on it, enable EVC. For AMD separately will be there, for Intel separately will be there. Click on OK. Here you need to select generation and click on OK. So you have to select which generation you want to apply. This will be, you need to check that compatibility, that will show only the lowest compatible processor. If you go select cluster, configure tab, VMware EVC, edit, enable for AMD separate. If you have AMD host with generation 2 and generation 3, you can select these generations. If it is Intel, select Intel, and there are multiple generations. How to check which one is suitable for your host? Select one generation at a time. Remember, select first one, Mirom. It is not compatible. Clearly it is showing alert. Select next one, not compatible. Select next generation. No. No. Not compatible. It's showing compatible. So when it shows compatible, you can click on OK. Okay, that it will enable EVC. Right now there is only one host. If you enable also, it's of no use. If you want to enable, you can enable such a way. Clear? Okay. That's the advantage of EVC. It will help us to migrate from older CPU host to higher CPU host, and then you can remove the old host. If you want to migrating from older processor host to newer processor host, we can use this feature. Clear? So remember this, just interview point of view, it's very, very important. So any questions from UEC? You will not have any work daily on this EVC once in 2 years, whenever 2 to 3 years. Your customer is upgrading your hardware. At that time, if you want to migrate VMs from old cluster to new cluster, we enable this EVC. Okay. So in some situations, without talking about EVC, they will give a scenario. I have a old cluster and old storage, and I have a new cluster and new storage. It's a latest CPU, latest hardware. You will not mention about CPU. You will say latest hardware on the new cluster. I want to migrate VMs from old cluster to the new cluster, old hardware to the new hardware. You'll just mention only just hardware. Then along with the plan, yesterday we discussed, right, connecting the storage, another cluster storage to the another cluster, and also you need to consider EVC as well. Storage connectivity and EVC you need to think of, and also network. 3 things you should consider. These 3 things you should consider: EVC and the cluster, to migrate from older CPU generation to newer CPU generation. Shared storage, if you want to come, the scenario is like this. I'll just quickly write the diagram. This is old cluster. This is one cluster and this is another cluster. You want to move virtual machines which were stored here on this data store. This is completely old hardware. You want to migrate from old virtual machines without business impact to the new hardware. Completely from old cluster to new cluster. In this case, connect the old storage, okay, new, whatever it is, new storage. Connect the storage array like this. Create data stores here. That we know how to talk to the storage admin. Share the www address of old host. Ask them to connect the new storage here. They will create the LUNs here and they will map to us. We will create as a data stores from here. Now, this old host, this is old and this is new. First SV motion from these the old data stores, you try to SV motion to new data stores. So virtual machine files will come here. Now virtual machines have been migrated from old data store to the new data stores. VMs are still in the old cluster because old host can see old storage and new storage as well. Files are already moved to new storage. Only now VM should be migrated. VM to migrate, so to migrate VM files from one data store to another data store, that's what we are considering shared storage. To move the VM from one host to another host, processor will be high. If it is a new hardware, definitely processor will be higher. You need to consider EVC. If you just migrate this one, that's fine, it will migrate. But what about network? VM will lose connectivity, right? The same network should be available here as well. So for that, same like vMotion. We're just using vMotion, right? We should not lose network connection. So use. So these are the three things you should consider when you're migrating from old hardware to new hardware. Clear? Any other